Welcome to The Explainer, where we break down big ideas. And today, we've got a really cool one. It's about a huge shift in AI and how we realized that teaching a computer to understand the world meant we had to embrace, well, a bit of a mess.
So let's just jump right in with a question that sounds simple but really isn't. You look at a picture, you read a caption, and snap, your brain just gets it. The connection is instant. But how in the world do you get a computer to do that? Take this, for example. We see Monet's haystacks. We read the words "a painting of haystacks in a snowy field," and it's just obvious. It's second nature. But for a machine, that's a massive, massive challenge. And for a long, long time, we tried to solve it in a very specific, kind of rigid way.
All right, so to really get why this new way is such a big deal, we got to look back at the old way of doing things. And the whole problem, the big roadblock, it all came down to one thing: data.
For the longest time, everyone thought the only way to teach an AI was to spoon-feed it perfect data. I mean, think about it. Millions of photos, and for every single one, a human had to sit down and write a perfect little caption. A cat sitting on a mat, a red sports car. You can imagine, right? It was super expensive, painfully slow, and just took a ridiculous amount of human effort. It was a huge bottleneck. We just couldn't scale it up. And the researchers behind this new model, it's called Align, they put it perfectly. They said this whole process of costly curation was basically holding AI back. The models needed way more data than we could ever hope to label by hand.
So clearly, something had to change. And that's when researchers decided to try something kind of crazy. They took that old conventional wisdom and just flipped it on its head. They asked, what if the secret isn't perfect data? What if it's just a ton of data? And I mean a lot more. We're talking about a data set with over 1.8 billion image and text pairs. And they just scraped them straight off the public internet. To put that in perspective, that's hundreds of times bigger than those fancy curated data sets we were just talking about.
But here's the real kicker, the secret sauce. They didn't spend years cleaning it up. Nope, they just embraced the mess. They took this huge pile of data, with all its noise, all its typos, all its imperfections, and just used it as is. And this is a perfect example of what I mean. The text that goes with this picture? It's not some neat little sentence. It's the raw file name. File Frankfurt Airport Skyline 2017-05 JPG. It's messy, right? But you know what? There are still good clues in there. Frankfurt Airport, Skyline. The AI can work with that. Here's another one. File London Barge Race 2 JPEG. This really shows you what noisy data is all about. The AI isn't getting a perfect English sentence. It's getting bits and pieces, file names, random text from websites. Its job is to figure out how to find the important stuff, the signal, buried in all that noise. So the whole idea, the really crucial part, is that the researchers made a bet, a big one. They bet that the massive quantity of this messy data would actually be more powerful than a much smaller, perfectly clean data set. They were betting that in this case, quantity could totally beat quality. Okay, so you're probably wondering, how does a machine even begin to learn from this chaotic mess of pictures and random text? Well, the answer is a really clever training method. It's called contrastive learning. And honestly, the best way to think about it is like a giant, super fast matchmaking game for the AI. So here's the game. First, the AI turns both the image and its text into a kind of numerical code, like a digital fingerprint. Then, it gets shown the correct pair, the image and its real text, but it's mixed in with thousands of totally random, incorrect pairs. Its only job is to pick out the one true match. And it just does this over and over and over again, billions of times. Every time it gets it right, it gets better, and slowly but surely it starts to build a real sense of what words go with what pictures.
So, did this crazy bet pay off? Oh yeah, big time. This whole method unlocks some absolutely incredible new abilities for the AI.
The big result is something called zero-shot classification. And it sounds fancy, but the idea is pretty amazing. It means the AI can now identify things in pictures that it was never, ever specifically trained on.
So look at this. The AI was never explicitly taught, this is what a Madagascar cat looks like. It never memorized the list of animal photos, but because it read the words describing these things millions of times next to different images, it learned the concept. So now it can look at a photo and make a really good guess, and it can do this for pretty much anything.
But this is where things get really wild. The AI's understanding is so flexible, it can do more than just name things. It can start to do a kind of conceptual reasoning. You could almost call it visual math.
Okay, check this out.
What do you think happens if you take the AI's internal idea of a panda and you mathematically add its idea of the word Australia?
It's like the model has to ask itself, what's a fuzzy, black and whitish animal? But the Australian version. It's literally doing math with ideas.
And what does it come up with? A koala. I mean, that's just incredible, right? It shows this isn't just about matching pixels. The AI is starting to understand concepts. It's connecting the visual world with the world of language in a way that's, well, it's totally new.
So, let's zoom out. What's the big lesson here? What does this whole shift from perfect, clean data to giant, messy data really mean for where AI is heading?
Well, you know, the numbers really speak for themselves. When you put it to the test on standard benchmarks, this model, Align, which was trained on all that messy internet data, it performed just as well as its competitors that were trained on the expensive, clean stuff. In fact, it was even a tiny bit better. That big bet they made, it paid off. And this idea, it seems simple, but it's so powerful. That sheer size can be more important than perfect quality. It's totally changing how we build AI. By just letting the machine learn from the chaos of the real internet, we've unlocked something huge. It really makes you wonder, right? If an AI can learn this much from the messy, chaotic internet, what's the next frontier it's going to conquer?